Okay, so they show us an f of x, and they threw in its derivatives, and then they ask us to answer some questions about where it's positive, where it's decreasing, where it's concave down. Well, I think this is too much information and it's a little cluttered and distracting, so I'm just going to clear out some fluff we don't need. We'll get rid of this second derivative, and we'll get rid of this first derivative. We don't need them to give us that. We can figure that out just looking at the original curve because we are awesome at this. Right? Okay, here is our original function f of x. It looks sort of sinusoidal. We're not sure it's a sinusoid, but it's got that general wavy shape. And let's see what we can figure out about it. First thing they ask is where is the first derivative positive, which means where is the slope positive? In other words, where is the function increasing, or where is it going uphill? This is downhill, that's downhill, 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 flat. It seems to be uphill from this point all the way over to there, and then it stops being uphill. Now, the alignment of these letters isn't super, but I'm pretty sure they meant that to be from B to C. So you could do something like B, C for that interval. That's where the function has a positive derivative, first derivative, meaning it's going uphill. Where is the function concave down? Remember what the concavities look like? Basically, a concave up function looks like a happy face, and a concave down function looks like a sad face. It's got curvature that gets lower and lower as you go on. Or concave up looks like a plane pulling out of a dive, and concave down looks like a plane where you're pushing forward on the column, you're coming out of a climb and going into a dive. Where is that happening? Well, this is concave down. We're diving faster and faster. That part looks like sad face, but not all the way down, only until somewhere in here, and then this function starts to curve back the other way. So this I would call concave up, concave up, concave up, concave up. In here it's almost straight and it gets a little hard to decide, but somewhere around there it resumes being concave down, and it stays concave down until, oh, now it's getting straight and it's hard to tell again. Somewhere in here, it goes from being concave down to once again being concave up. By here, it's clearly concave up. So, how would we describe those intervals? This looks like it's up to A. The trouble is I don't know what to say for where this begins. We could assume it's just minus infinity, which means it stops being a wave, and I'm not delighted with that. But or we could just say less than A to kind of avoid giving an interval. I was not excited about writing minus infinity comma A because I don't really know what the behavior is over there. But to the left of A, it is clearly concave down, and then it's concave down from roughly 0 up to very roughly C. That's not a really good match, but I guess the inflection could be there. That's not totally unreasonable. Okay, what else have they got for us? Oops. Okay, I deleted too much. Now you got the derivatives again, but I'm still going to do all these questions just working with f of x because we don't need all this extra information. Next one, where is the second derivative positive? If the second derivative is positive, what does that mean? Second derivative is the one about concavity. If it's positive, it means we're concave up, so we have the happy face curvature. That's not true here, or here, or here, or here. Somewhere around here, this function inflects and becomes concave up. and it stays concave up all the way to, could it be 0? Somewhere around 0, it inflects again and goes to concave down. Then, somewhere around here, it seems to inflect and become concave up, and it's definitely concave up by the time you get to D. So these are the two parts that have happy face curvature. That means they're concave up, and it means the second derivative is positive. It's bigger than 0. So how do we describe those? This would be from A to 0, I suppose. That's pretty clear. And we also have from C to D. All right, that went okay. And for our last one, where is f of x decreasing? Decreasing meaning it's got a negative first derivative or it's going downhill. That's all. And where are the places on this function where it's going downhill? This is downhill. Downhill, 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 downhill. Right there it goes flat. And after that it's uphill, so we wouldn't count any of this. That's all uphill. Uphill, uphill, flat, start counting. And downhill, 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 downhill. So for those intervals we get left of b or less than b. Again, it clearly is decreasing to the left of a by quite a bit, but I don't want to say it's from minus infinity to b for something that looks like it's wavy. I'm just going to use this to kind of fudge my way around that bit of uncertainty. And then it's decreasing from, we could pretend that's C. It doesn't line up incredibly well, but from C to D. And there we go. So you can graph the derivatives separately and try to get information out of them, but in a lot of cases you don't need to. Once you understand what the derivatives mean, which is what we really want you to have, you can pull that information right out of the original curve by saying, is it going downhill or uphill? That's the first derivative. And does it have downward curvature or upward curvature? That's the second derivative.